We've decided to create a game of tic-tac-toe as one of our first C programs that will use multiple functions. This will help us learn how to use functions in our code, right? And in class, we walked through this set of slides, an algorithm of how we would create a tic-tac-toe game. We developed an algorithm. We said we'd start simply by, we want to play a game of tic-tac-toe, right? That was our problem statement, creating that game. And then we have to ask ourselves, where we'll start, right? We always analyze the problem. We need to make sure it's clearly defined and understood, right? And then we start determining a solution after we've understood what our outputs are, what our inputs are, right? And our solution design will constantly be refined, right? We'll come up with a set of criterion. As we start to develop, we'll find that we have more questions that we have to answer. We'll have things that we want to change, and we'll keep iterating through that design process, right? We might find some other things as we're coding the solution as well. We might have to make some appropriate changes to the program or in the design as we test and correct. So this is sort of an iterative cycle, right? Where we'll go back and reassess requirements as we design, develop, and test, right? When that's all through, you have your final implementation, right? We started out with tic-tac-toe or any problem by analyzing it. So we have to make sure any problem's clearly defined and understood. For us, we want to understand what output is required and what input will be needed, and we need to understand the rules of tic-tac-toe. There's a link right to the game here. You can, if you've never played it before, right, go out and play a few games online to see how it's played. But basically, it's a game, right, where the objective is to get 3 X's or 3 O's in a row to win, right? So we'll start by defining the rules, right? As I just said, we want to get 3 in a row. That's our objective, right? We play on a 3x3 game board. The first player is known as X and the second player is O. And the players alternate placing X's and O's on the game board until either opponent has 3 in a row or all 9 squares are filled, right? And that would result in a tie. Some other things we could consider as we're writing a program is, do we want to write a program where one human will play another, just use the computer to do it, or will a human play a computer, or will we have a computer versus a computer? And in our game, we'll just write it so one human can play another, right? That's the easier of the algorithms to write. We need 2 players in to play a game, and the game starts by the 2 players agreeing to play, right? And so we'll want to do something like that with our code. We'll want to ask the user, do you want to play a game? Right. Once the users have said they want to play a game, right, we'll draw a game board. So here's just sort of an empty 3x3 grid, right? As the game proceeds, player X takes the first turn, right? And then before player O takes a turn, you both evaluate, is there a winner? Clearly there's not a winner in this case, so O will take a turn. Right? Again, there's no winner. So the X will take a turn and the game will go on until there's a winner or a tie game. So having gone through this, we've decided to play a human versus human game, right? We're going to ask the players whether they want to play a game before it starts. We'll need to go ahead and draw a game board. Let X take the first turn. We'll check for a winner or tie game. O will take the second turn, and then we'll check for a winner or tie game. And we'll keep doing that. We'll say, while there is no winner, tie game, keep playing. So we're starting to develop, right? As we analyze the problem, this will be easy to turn into an algorithm to solve it. Our implementation will be in the C language. So that's already been decided for us. We use the keyboard to input our information, and then our output will be showed in the console terminal window. So here's an example of what it might look like, right? We might pop up a menu here that gives the user a choice as to whether to play with X or O, and to fill in a game board. And so when our program starts, what we want to do is we'll create some sort of start screen, and then we'll display a menu with user choices, and we'll give the user these 2 choices. Right? And when the user chooses to play a game then, right, we will go ahead and display the game board. So we want to consider then when we display the game board what information needs to appear, right? And we know that if we were doing this on pencil or paper, we draw an empty game board. And one of the best ways to write a program is to actually play a game, right? Play it on pencil and paper. All of the steps that you perform on pencil and paper, you're going to turn into an algorithm and then turn into program code, right? And we might want to do something like this. We might want to actually number these squares 1 through 9, right? So that the user can enter a number 1 through 9 to do that, right? So our general algorithm or pseudocode so far will be display start screen, display the user menu. If the user chooses to quit, we'll end the program. Otherwise, we'll start a new game. While the game is not over, we'll display the game board. We'll let users take a turn, right? Then when the game is over, we'll display a message saying who won or whether there was a tie game. And then we'll prompt the users again to ask if they wish to play another game, right? So let's just go ahead and think about how we want to implement this in our C program, right? So what I've done here is I've got a code blocks project, right? I've got a new blank C file, blank except for these comments, right? And I've then written or typed in comments of description of what the game board will look like. So here I've decided to start with 0 is the number for this position. And what we're going to do is we're going to store the game board in a one-dimensional array, so a 1D array. And the array index values are going to correspond to positions on the game board. And so I put this in our comments so we know what those positions look like. What we'll do is, right, all of our C programs start with main. We're going to have to create a game board. Now, it could be type char, short, int. I guess out of habit here, I'm making this an int, right? It's going to be an array. So I'm going to just call that game board. And it's a 3x3 array, but I want to represent it as a 1D array because in this assignment we'll work with one-dimensional arrays, passing them to and from functions, right? So in this case, if it's 3x3, right, that means we have a total of 9 elements in our array. All right. Now we've created the game board array. Right, it's got garbage in it. We haven't initialized it to anything. What I'd like to do then is think about how we want to represent information on the game board, right? Lots of different schemes we could use. I'm going to use this scheme where I'm going to use some macros. So I'm going to define X player to have a value of 0. I'm going to define O player to have a value of 1. I'm going to define a spot on the board as being open with a number 2. And eventually we're going to need a mnemonic to represent a tie game based on the way I've decided to implement this. Right. So I'll just make that 3. Doesn't really matter, well, it sort of matters what the numeric values are. I want them to start with 0, and I'll show you why in a little bit. It's going to do with the way we represent items in the game board. All right, so we could then go ahead and initialize our game board to open, right? If you think about it, if we're going to start a game, we're going to have a game board that has no X's and O's in it, right? So what we can do is we can initialize all of that to open, and let's write a function that does that. So initialize all elements in the game board as open, right, or set them to open. Right. So if I want to write a function to do that, I think I'll just call it initialize game board. All right. And if I wanted to work with an array, right? Well, here in main, we've got this array called game board, right? In order for my function to work with the game board that we define here in main, we need to pass that array to this function. So that means I'm going to have one parameter in the list. I could call it board, I could call it game board, right? I can call it the same name, I can call it a different name. Probably just likely refer to it as game board. All right, so whenever I put parameters in a list, they have to have a data type, right? And they have to have a name. And to indicate this is a 1D array, I put empty brackets, right? Now, normally, whenever we pass arrays to functions, we always pass the size as well. Tic-tac-toe is sort of a special case where we're always going to know the size of the game board. But here, and that means we're never going to come back and recode the game board, right? Tic-tac-toe is always going to be a 3x3 array. In this problem, if it's always a 1D array, I could use that information within my function to know that I'm always working with array elements of 9, right? So we'll do that here. So to initialize the game board, I'm going to create a loop. I'm going to start with element 0, as long as this is less than 9. Right, we will just iterate or loop through the board, right? And we'll just say game board. Right. I'm using game board because this is the name I gave to the game board here. So game board at index I, and I'm just going to initialize all these spots to open. Right. Now, in order to use the function, right, in main, I'm going to call that function. And I realize that we are not following along with every step of the algorithm. I just wanted to start with initializing the game board and displaying it, as most people are fairly comfortable with doing that much, right? As the complexity of the game or of the algorithm increases, having this much work done will help us then test our code. Right. So initializing the game board. In order to do that, from main, I call my function called initialize game board, right? I have to call it spelled the same way as I did up above. Now here in main, the name of my array that I want to pass to this function is game board. I end up with a semicolon. All this needs to do is fill my game board with open. This function does not need to return anything, so my return data type is void. We have to remember that when we work with arrays, right, when we pass arrays to functions, passing an array, like passing a constant pointer to an area in memory. So this function will then be able to access this memory and make changes to it, right? It will be able to write over that memory. So whenever we get back to main, we'll see that this memory has changed. All right. So let's just try a run to cursor here. And it looks like I put a breakpoint in. Return with no value, it gave me a warning. I just said return instead of return 0. All right. Now, I thought I aborted the debugger, but it appears to have come up. Okay. Here in main, we can see the game board just has whatever garbage in it. If I now say, if I go to the debug window and say, step into, right, I will now actually step into this function here. Right, now here we see the game board is simply a pointer. That is, so this hexadecimal notation is an address. It's the address where this game board is stored in memory, where main's game board is. Notice I hasn't been initialized yet. If I say next line, well, then we step through. In this case, I'm going to store open in game board 0. So if I want to see that here, I can type game board 0. And now I see a value of 2 there. Well, 2 is the number for open. Right, so as we continue to step through this, we want to see the other array elements. Right, we could do that. We could type these in, but I'd rather just go ahead and look at them when I get back to main to see that they've been making that change. All right, so I still have the garbage there. As soon as we execute this line where I is equal to 1, right, that updated that. All right, so we could just continue to step through here, right, as this fills in all 9 positions. Right? When this is finished, then this function returns back to main. So back here in main now, right, we can see that the entire game board has been filled in with values of 2. I can delete. All right. Going to stop the debugger. And I just really want to remove that breakpoint, but won't worry about it now. All right. So what I want to say is back here in main, I called this game board. Well, I could call this something else here. I could just call this board, right? Any other name. So if I just call this board here in this function, right, I have to use the word board here because I have to use the same name as in the parameter list. Here we use game board because the array, we refer to it here in main as game board. Here in initialize game, because we gave it this name in the parameter list, we refer to it by that name here, right? And if we did this and we did another run to cursor, right, that rebuilt. Right, when we get back here, it has filled into our game board. So it still works the same. I just wanted to make the point of these names do not have to match. Right? This parameter is local then to this function. It has access to this memory back here because it's an array. All right, let's stop the debugger. All right, now that we have our game board initialized, let's write our function to display the game board. Oh, here's the other thing I should mention being new to functions. Right? Notice I wrote this function before main. So I'm going to cut it out. I'm going to put it below main. Right? The compiler is going to give us an implicit declaration warning because the compiler starts at the top of our file and starts working through. When it sees this function call to initialize game board, but it has not yet read anything about this function, it's going to produce a warning. So if we compile this now, really don't know why this is. Oh, all right. Didn't have. I was clicked on a different link or tab and didn't see the build message come up. So let's just go ahead and clean the workspace so that now I can recompile and show these warnings. All right, so here's this warning: implicit declaration of function initialize game board. Right? That's because the compiler read it here in main before it was defined. So one way to then define our functions is to go ahead and list the function prototypes. A function prototype is nothing other than the header of this function. So the header is the return data type, the name, and the parameter list. And then we end that with a semicolon, and that's declaring the existence of that function. So now, if I compile, now we don't get that. So now the compiler knows that we're declaring the existence of this until it gets down here, right, and reads through the definition of how we're implementing it. It doesn't know how it will be implemented, but it knows it exists later on by this declaration, or that it should exist later on. And so then we can go ahead and call this function before we fully define its behavior down here. All right, that's prototypes. Now let's go ahead and write our display function. All right. So this will simply display the game board. I should be consistent if I'm going to use underscore. So display game board is going to need access to the board, right? And we want to do something like go ahead and print out this information. We want to let the user know what the different values are that they need to type to enter things on the game board. So we could do that simply with, we could do it with printf or puts, but all right. So we could literally hard code in here, and let's control the width of this. Maybe let's make this 3. So this is a string field that's going to be 3 wide. And then we're going to have a vertical bar, and then we'll make the next string field 3 wide, vertical bar, and then the next string field 3 wide. And so into that first string field will be 0, into the next will be 1, and then into the next one here will be 2, right? Even though those are single, that's a string because I put double quotes around it. Right, let's just go ahead and run this and see what it looks like. In order to run it, let's call this function here from within main. So display GameBoard. Right. And I need to pass it GameBoard. It's expecting 1 argument. All right, build and run. All right, so that doesn't center, that right justifies. So when I didn't leave any spaces in between that, let's not, doesn't look quite like I want it to. So maybe I'll put a space there, a space here. Maybe we should just make these 2, right? Because we're only going to have the numbers 0 through 9. All right, that looks a little bit better there. All right, so the next thing we'd want to do is we'd want to print out, all right, we could literally just hard code in 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, right. And I'm going to need a new line there. And let's put a new line here. And let's maybe put this a couple lines down when we run. All right. Not quite the spacing I wanted. I need to move that over 1. I need a blank space there. And then all right. This will be 3, 4, and 5. All right. That's not looking too bad, right? We could always work on a static slider, but that's not too bad for a first attempt, right? So that just prints out our game board, right? And shows the user then what the different positions are. We might want to put a title above it. We might want to say game board. I think the user will know what it is without us doing that. All right. Now below that, then we'll want to show the current state of our game board every time we display it, right? These are just our hard-coded positions. Here, we want to show what's actually in the game board. All right. We still want to use some sort of structure like this, right? But let's see what would happen, right? All right, so our game board, then, our data type of our game board is integer. So if I made this a field width of 2, if I made all these D because they were integer, and then we said, well, okay, board at index 0, right? Board at index 1, show us what's in the game board in those positions, and then board at index 2. Right? Right. So as we run that, well, it showed us what was in the game board. Remember, we called initialize game board and we stored the number 2 in there. Right? But we don't want to show 2's to the user. That's confusing. We probably like to show the user a blank space. And when we store x's in there, we're going to want to show an x, right? And when there's o's, we want to show an o. So what we're going to do is we're going to make a global constant array. We're going to make a global constant. It'll be so const char, right? I'm going to let my initializer list determine the size. All right. Here, then I'm going to put an x. I'm going to put the character capital O, and here I am just going to put a character that's a blank space. All right. Well, let's take a look at what happens if we were to, oh, I need to give this a name. Right. Anonymous isn't good, even though it's legal. All right, I'm going to call this character display. Right. Let's take a look at then what happens if we access this. Right. Character display at index 0 will be the character X, index 1 will be the character O, index 2 will be a blank space. Notice I didn't put a size here. I could hard code in the size here. That will make it 3. If you leave this empty, then it's 3 based on the number of items in the initializer list. So there are 3 items in the initializer list. This will have a length of 3. Like I said, if we want to just go ahead and show what's in there, right, let's go back down here to main. Let's turn off these 2 functions, the calls to the functions, and let's just go ahead and print out. So we're just going to print out then %C, 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 actually. And that array is called character display. So character display at index 0, right, will return the character X. Character display at index 1 will return the character O, and character display at index 2 should print out that space character. So let's just actually, let's put a couple of new lines and maybe a tab so we can see that in the output. So build and run. All right, there's our X. So that is character display at index 0. Right. Our O then comes from character display index 1. Then our blank space, right, it's just a blank space. We really can't see if it's there or not. I'm willing to bet that it is, though. Right? So we want to make use of this character display array, because look at this. We just saw that when we display what's stored at index 0, we get an X. We get a blank space for index 2, right, and an O here. So what if here, so when we reference board 0, let's just get rid of that for right now. Let's just go ahead and turn these function calls back on. Let's go back to what we had. So when we build and run this, right, we saw then we were just printing out the first row here of what's stored in the board, and we got all 2's. We said we'd like to have blank spaces here. So board at index 0 returns a value of 2. If I use that index value of 2 to access character display, we'll get whatever character to store them. So character display, right? If I use then what's returned by board at index 0 as the array index, for the characters we actually want to display. So board at index 1 returns a 2, so that's like saying character display at index 2. Right. Board at 2 has a 2 stored in it for open. So we're going to see then that this should give us blank spaces, which won't be really easy to see if they're just, well, we'll see them in between these vertical pipes. Let's go ahead and print out another set of lines there. I got 32. Well, I got 32 because I didn't change the D. So I just, before we were using the %D there, right? I have to change that to a C. 32 is the ASCII representation for a blank space, and that was giving me the integer value of that, right? Not what we wanted to see. Now I'm going to use the %C, right? Now we get our blank spaces when these are open. Now let's just go ahead then and use this same idea, right, for the next row, but that's board at index 3, 4, and 5. And finally the last row, right, will be index 6, 7, and 8. All right. And so now we get the behavior we'd like. We've got our board initialized. We're able to display it at this point. We'll go ahead and end this video here, and then we'll come back and start talking about what we need to do to start implementing the algorithm. But we've got a good start now simply by being able to initialize our game board and displaying our game board as well.